Graphing a rational function is going to use a lot of the same techniques that we normally use for graphing other functions. So our first thing that we're going to need to do is just get a general shape for the rational function so that we can graph it. If we make a table of values, the table is not going to work for 0. If you plug 0 in, it will be undefined. So that's going to be our horizontal asymptote, and our vertical asymptote will be at y equals 0 and x equals 0. And if you're not using different colors, you can just kind of make it a little bit lower or higher or a little left or right of the axis. All right, then if we plug in points that are not 0, I'm going to do -3, -2, -1, and 1, 2, and 3. We'll kind of simplify the table down to just 4 points in the future. And then it's just plugging in the fractions. So it's going to be -1/3, -1/2, and so on. And honestly, when we go to actually do the graphing with the transformations, we can just use the table that I boxed off so that it's not as much work to do, because you don't really need a lot of points to figure out where to put them. So 1, 1, and -1, -1 are important. That kind of tells you where the branches are going to go. And then even the 2 and the 1/2 and -2 and -1/2, just to see that it's going that direction. But the branches are going to nest inside of the asymptote lines. Remember, just like log functions, you want to get it close to each of the lines, but you don't want to actually go through them. So that's the important part of those. And then for domain and range, it's a little different because we have two different pieces. So if I do the left piece, it's going from -infinity to 0 with parentheses. And then we have a right piece that's starting at your vertical asymptote line, also starting at 0 going to infinity. And the x equals 0 is the reason why it's starting and stopping at those points. Because remember, domain is the set of all your x values. Range is going to be the same, except that the 0 is coming from the horizontal asymptote of 0. Now, when we do translations, that obviously is going to change a little bit. You might not have the exact same domain and range, but just realize that the domain is going to come from the change in your vertical asymptote. The range is going to come from the change in your horizontal asymptote. I'm not saying you have to memorize these domain and range starting points, but it is good to know kind of what it looks like, because it'll be similar every time. All right, down below, we're going to go back over the transformation rules, which you should be pretty comfortable with at this point. So this time the denominator is kind of where your parentheses is going to be. If it's a -h and it's in a parentheses, you're going to go right. If it's a plus, you'll go left. If the number is not part of the function, then that's when you go up or down. So positive is up, negative is down. And then we also have vertical stretch and reflection. So if you have a number on top, it's going to be a vertical stretch by a factor of A. And then the negative on the top is going to be reflect over x-axis. And we're actually only going to do reflect over x-axis for this, so you don't have to worry about y-axis. So I know the intro stuff kind of takes a little long, but we're going to move into the first example, which will wrap up this video, and then the other examples we'll do in the second video. So if you need to take a pause for a second, that's totally fine. But we're going to move on to that first example, identify the transformations, and then work with the critical points. All right, so here you're going to see on the 3 on the top means vertical stretch by a factor of 3. And then the -2 on the outside is going to be a translate down 2. That's going to tell you what your horizontal asymptote is. Since you did not go left or right, your vertical asymptote is going to be still at 0. So you can actually graph that right away before you even plot any of your points. And I'm going to do that right now. Okay, and then for critical points, we're going to use the 4 points instead of all the ones that are on the front to start off with. Again, you kind of need to know the starting table for these. Vertical stretch means you're going to multiply the y column by 3 first. And then down 2 means you're going to subtract 2 from your y column also. So you want to kind of do that in 2 separate steps. So what you'll notice is I changed it over to 1.5 instead. You don't have to do that. It just might be helpful for subtracting the 2. You can use your calculator to get the fraction form, but I think it's a little easier to graph it when you see it in that format. So now I'm going to plot those points and connect the branches. You can kind of see the vertical stretch just pulls it away from the asymptotes a little bit more in the middle section. Our domain is going to be -infinity to 0, matches up with the vertical asymptote. And then the range is going to be -infinity to -2. Again, that matches up with the horizontal asymptote. So really, it's going to be the same every time, and you're going to match it up with each of the asymptote lines there. If you're using your calculator and you plug this in, the key is to look for where the error message is, because the points surrounding that error message are going to be the points you'll want in your final table. So that wraps up this video. You're going to want to take a look at the second video to watch the other 3 examples.